when I talk about three-dimensional figures, the two measurements most often we talk about on those particular figures are the volume and the surface area. So first of all, let me just mention a couple of the figures that we'll talk about. So when I'm talking about a three-dimensional figure, you know, one of them that we'll talk about is the box. You know, just a regular box, three-dimensional box, length, width, height, that sort of thing. What are some others? Well, we can talk about, you know, the three-dimensional circle, which is a sphere or ball. We will talk about that, but some other ones we'll do the cone shape, which is you got a circular base, and these, you know, these get a little more fun to draw. So we got a cone, cylinder, can shape, where you have a circle, top and bottom, kind of a cylinder shape there. But we'll also talk about a couple other ones that, you know, we're familiar with those, but we'll also talk about well, probably familiar with the pyramid, so let me throw that one up there. Now, the deal on these, the pyramid and the other one I'll talk about also, the deal on a pyramid, we usually think of, you know, the pyramids in Egypt, which those are perfectly good pyramids, don't get me wrong, but that's not the only shape of a pyramid that we can have. You know, those pyramids in Egypt, what they do is, you know, they have a square base, right? Those pyramids, I believe they do. But a pyramid doesn't have to have a square base. It can have a triangular base. It can have other shapes as bases as well. Say that one there connects up with that one. That one's got a triangular base. And so that complicates pyramids a little bit because the shape of a pyramid can change like that. But we'll talk about that a little more in just a second. And the other one is the prism. Let me go ahead and talk about that just a little bit. The prism, the ones we'll talk about are the ones that have a congruent, and usually when we think of a prism, we usually think about the triangular shaped prism, I guess you might say. So the deal on the prism is you've got the top and the bottom are the same. And in this case, we've got a triangular top and a triangular bottom there, or bases. It's a triangle. And then you've got a congruent triangle in the base there for the base. But the deal on the prism is the same thing can happen on a prism as it does with a pyramid. They can be any type of polygon, because like here, we could have that be our top, and so the bottom is congruent to that. And hopefully that kind of looks like a trapezoid. So you can have a trapezoid on the top and bottom for your prism. So same thing can happen on those as can happen on the pyramids. They can be a different shape, top and bottom. So we'll talk about that, what that would mean to what we're going to calculate on them. All right, so let's talk about volume and surface area, what that actually means. Yeah, so when we measure volume, what is it we're measuring? When I say what's the volume of something, we're talking about
The inside?
the inside, yeah, how much it'll hold, the capacity that it will hold. The inside, yeah. It's how much can go on the inside, right? Okay? Well, that requires a different type of unit because centimeters won't work because centimeters just measure distance. Centimeters squared won't work because that just measures areas, an area of something. So what you have to do to measure volume is you have to go to a three-dimensional unit. And so that's, let's say it's, again, I'm picking on centimeters here, but 1 centimeter by 1 centimeter. Yeah, it's a cubic unit, right? You got a cube, and you're going to figure out how many of those cubes will go into a figure. That's going to be your volume. So a centimeter cubed unit is one example of a unit that we'll use. And so, yeah, units that we use are cubic units for volume. And centimeters cubed is an example. Cubic inches, cubic feet. If you get bigger, cubic meters could go up to cubic kilometers, I guess. But yeah, so for volume you have to use the cubic units because you have to figure out how many of these things fill up a figure. Now the surface area, on the other hand, that one's descriptive of what it measures. Surface area doesn't measure the inside, right? As the name suggests there, surface area just measures the area of the surfaces. So it's the area, let's say total area of all the surfaces, just like the name suggests. And so, yeah, that's basically how you do the surface area, is you just add up all the surfaces. Whether they be rectangles or triangles or trapezoids, whatever they are, just add up all the area of the surfaces. And so this is an area, and so area units, still square units, yeah. So the units of surface area are your square units, just like areas previously we did. So it's a square units. Centimeters squared, inches squared, square inches, what do you say? Okay? So those are the two things we measure. So let's talk about it. Let's start with the box. Yeah, so in a box you've got three different dimensions. You got a length, you got a width, and you got a height. I'll use capital letters here. And so we're going to come up with the formulas. You may already know them, but volume and surface area. Start with the volume. Yeah, what I like to kind of demonstrate is just give you an example here. If I had a, let's do a 4, a length that is 4 units long, so that's our length. And then let's do a height, of 3. So we got a 4 length, height is 3, and then we'll do the width is 2. Well, it's pretty easy to show here how many cubic units there are in this particular figure, because, yeah, if we just kind of grid this off, then go back like this, and then like this. If we grid it off like that, you can kind of see I've got a front row and a back row, right? Of these cubic units. Each one of these is a cubic unit, 1 by 1 by 1 unit. Right? You with me there? So I've got a front row and a back row. Well, if you count up the number of cubic units I have there, the front I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? I've got 12 in the front, 12 in the back, so I've got 24 cubic units there. Well, it's not hard to see that to get the 24, instead of having to grid them off, can I just do 4 times 2 times 3? Isn't that 24? 8 times 3 is 20. Yeah. So it's not hard to see that, yeah, for the volume, you're just going to multiply the length times the width times the height. Pretty easy formulas as formulas go. Now, while I'm thinking of it here, we're going to get several more formulas today, volume and surface area. But good news for you is test day, I will have volume and surface area formulas provided. Okay, you won't have to memorize these. The other ones, the two-dimensional, like area of a circle, area of a trapezoid, area of a triangle, those you need to know. But volume and surface area, I provide those on. You don't have to memorize those. So anyway, well, I was thinking that, in case I forget. All right, let's talk surface area. Well, first of all, surface-wise, there are 6 surfaces on a box. You got a front and a back. I didn't show those, but it's a terrible line there. Okay. So I've got a front and then a back side to this. So there's 2 there. You got 2 sides, this side and then this side, and then you got top and bottom. So if it's a complete box, it's got 6 surfaces, right? So I need to add up all those to get the surface area. Well, also nice about it is several of the sides are congruent, right? The front and the back are the same, the 2 sides are the same, and the top and the bottom are the same. So let's think about all that. So let's just do the front and the back. The front area, well, the front, and the other good news is all the surfaces are rectangles, right? So the area of the front would be, well, it'd be the length times the height, right? Because that height is the same as that height. So the area of the front is the length times the height. Well, what about the area of the back? It's also the length times the height. So I've got 2 LHs for that area, for those areas, right? What about the 2 sides? Well, one side would be a W by H rectangle. So that area would be WH. W times H is going to multiply those 2 together. But the other side is also WH, so I've got 2 WHs. And then last but not least, the top and the bottom. Well, the bottom, let's just do the bottom. The bottom is LW, isn't it? So the area of that bottom side or bottom face surface is LW. So I've got the top as well. You've got 2 LWs. So it's a little bit longer formula, but that's the way it works. Now, let me do this. All right, so let's say I've got this box right here, and it's, let's make it 10 centimeters by 4 centimeters by 6 centimeters. All right. So easy enough. Calculate the volume. We got 10 times 4 times 6, so that's 240. And the volume units, they're cubic units, so it'd be centimeters cubed. The surface area, which I didn't mention, but they just use S for surface area. Surface area, so yeah, you just you just go through it, you do 2 times the length times the height. If I do it in the same order I did it, you don't have to necessarily do it in the same order, but you got 10 times 6, 2 times 10 times 6, and then you got 2 times the width times the height, so that'd be 2 times the 4 times the 6. And then you got 2 times the length and the width, so it'd be 2 times the 10 times 4. 120, 48, and 80 is, what's that, 248. And its area, so it's square units. Now the other problem I like on this, so I know that you understand the formula here, is, all right, so let's do the same box. So what is the surface area? I'm talking the outside surface area. If the box has no top. Surface area. So same box, but I don't have a top. So that changes the surface area because one of the, there's different ways we can do it since we've got the answer there, but let's just go all the way back through it. All right, so if I don't have a top, all right, so I've got front and back, I've still got 2 10 by 6s, right? I still got a front and a back, so I still have 2 of those. I still got 2 sides, so I still have 2 times 6 times 4, right? The sides are 6 by 4 sides. But I don't have a top, so how many of these 10 by 4s do I have?
1.
I just have 1. Okay. So there's different ways you can do it, but like I said, I like that one. Definitely shows you understand the formula. Is everybody okay on that? So it'd be 2 times 60, so that'd be 120. 2 times 24, so it'd be 48. But then I only have 1 times 40, so that's just 40. So that's just, what, 208? Anyway, I like that. Intent. All right. Question or concern on that? Now, a real easy one that, that's a square by the way. A real easy one that comes out of this one is, of course, the if I have a cube, so the cube is the three-dimensional equivalent to the square, right? Because a cube, all the sides are the same. So if one of the sides is S, then all the sides are S's. All right? So what does that make the formulas? The volume? Well, the length, the width, and the height are S's. S times S times S, it's S cubed. The surface area is, you know, for the box it's real long, but for the cube it's fairly short because all of them, if you think about it, all of them are squares. All the surfaces are squares, which the area of a squared is S squared. And so if it's a full cube, top, bottom, you got all the sides there, how many of those squares do you have? We got 6, right? Top, bottom, right, left, up and down. 6S squared is the surface area formula for a cube. Does that make sense? All right. All right.